Hello, I decided to make another stacked slices style plane using the building foam, and this is what it's going to look. Oh, you probably don't have a high enough security clearance for this, do you? Alright, never mind about that. But suffice to say, for this build I'm going to try and make it a little bit easier for myself, and instead of making the entire wing out of stacked slices, I'm just going to do it in a more traditional hot wire cut. So the hot wire is going to be running along the wingspan, and this is the wing section here. So in order to do that, you need to make sure that the lines are straight from the cord to the tip like this. So each one of these lines is just a straight line. But you can see already that it's a little bit more complicated here. We've got some twist, and the root section has some reflex in it as well. Plus, I wanted to make it a fair bit thinner than my previous plane. So it's going to be quite tricky to get a spar down the middle of it somehow. One way to do that is to drill a big hole, which is a bit tricky to do, especially when it's kind of thin. Another way is to just gouge a channel out of the bottom or the top and glue in a spar. And what I'm going to try is something a little bit different to both of those that I haven't done before. And I got this idea from another video on YouTube somewhere. But I'm going to cut out a slice like this, so it's not really a circular channel, it's just sort of a straight up and down all the way through. And I'm going to put in a piece of balsa, probably about 6-7 millimeters thick, vertically in here, and I'm going to try sandwiching the balsa with some composite, probably carbon fiber. And so this video is just about testing those materials, because this stuff is all fairly new to me, and I just wanted to see what sort of strength I could expect from it. So that's what this video is all about. These are the pieces I used for testing. It's 6.5 millimeter balsa, which is rather strange. I guess it's 1/4 inch is what that came from originally. Anyway, so they're 15 centimeters long, 2.5 centimeters wide, and the composites that I used here is, well, the two on the left are obviously carbon fiber. The leftmost one is unidirectional, 2.5 centimeters wide, so this is the same width as the balsa, quite convenient. The middle one is plain weave tape. The tape seems to be a fairly cheap way to get just a small piece of carbon fiber. This is the resin that I used. It seems to be fairly popular in the RC plane world. I don't know that much about all the stuff yet, but somebody in the comments asked me to make a video about it a while ago, so that's partially why I'm doing this. So don't treat me as any kind of expert. I'm just sort of learning things as I go. But one thing I did find out with in my experience with this stuff is that you really cannot be too sloppy with getting the ratio of these right. And I would recommend measuring it out to the gram, like I'm about to do here in this video. Alright, then we go to 18 from here. Got to do it before that resets. Okay, a little bit more is better than a little bit less of the hardener, I think. Mix thoroughly. This is how I layered everything. I put a little piece of peel ply on each side because I wanted to compress this while it was curing so that only the minimum necessary resin would remain on the surface. And in order to do that, you don't want to compress it with something that it's going to get stuck to. So the peel ply helps with that, and it also gives a nice finish after it's peeled off. And it also actually seems to wick away the excess resin. So instead of having the excess resin just sort of globbing out on the edge here as it got squeezed out, it actually gets pulled further and further away from the edge and becomes thinner in the peel ply. So that's what it looks like at about halfway before I put the second piece of peel ply on. And to make sure this was going to cure properly, I actually put it in the warmer tray of my oven, and I put this nice flat piece of wood on the bottom and a rather heavy piece of aluminium on top. This actually weighs almost 2 kilos, this piece here, and there's a piece of wax paper on each side of that to make sure that they don't get glued to everything as well. The smell of this stuff is actually way better than the polyester resin. That's another thing I've discovered. I don't think I'll ever be working with polyester resin again, to be honest. It just smells so horrendous that even just a tiny little bit of it somewhere makes the whole room stink. Whereas this West System stuff is actually not too bad at all. It does have a smell, It smells a little bit like mouse piss. If you've ever... I kept mice for a while when I was a kid, and their enclosure would smell like this after a while. So that sounds really terrible to say it like that, but it's very, very faint. And while it was in the oven, I couldn't smell anything at all, and the oven is fine. Oh, and the reason I did that was because the temperature here is a fair bit less than 20 degrees at the moment, and apparently this resin that I'm using, or more to the point, the hardener that I'm using with it, doesn't really go off until over 20 degrees apparently. Well, it will go off, but not very well. So this is what we get after curing. So the peel ply, with a bit of luck, will just peel off quite nicely, and you get this nice uniform finish that looks like the texture of the peel ply. It's quite fun to peel it off too. And this edge here, these bits here, become super tough. Yeah, it's hard to believe how strong they feel. Well, this, at least for this one, they don't quite feel so strong on this one, but maybe that's just because there's more of it sticking over the edge and less epoxy on there. This one's a bit harder to see texture, but it's the same. Wow, that comes off super easily. Anyway, so I'm going to just clean up the edges here and then do a stress test. I was just lifting the edge here and I was disappointed to find that it pulls away very, very easily. But then I was a little bit less disappointed to notice that it's actually, you probably can't see in there, but it's the actual balsa, the topmost skin of the balsa itself is coming away from the balsa underneath, so it's not the bond between the glass and the balsa that's breaking. But nevertheless, yeah, it's not really holding together as well as I hoped it would. Unidirectional, 6. Crisscross, 6. Fiberglass, 6. So they've all added 3 grams. They each weighed 3 grams before, now they each weigh 6 grams. Alright, let me show you how I have arranged to break these pieces. So there's a stationary part of the jig that sits there, and the workpiece, or the victim, will be slid into there up to that stopper. And then we have this other piece here, which is going to be the lever bar that breaks it. It's quite long, and it has on here at the end a load cell, and this load cell has just been calibrated with this 2 kilo weight there, so that when I press on the load cell, or when I press on the end of this bar, we should see some load showing up there. What does it say? I can't quite see that through my camera, but 600 grams or whatever there. And when I let it go, it goes back to 0. Now, I'm using my screen capturing software so that I can record what we're seeing there on the left, the numbers from the load, and we can also see this image, which is coming from the webcam right above the workpiece. So that will perfectly match up the timing between these two pieces of data. So instead of using my Handycam and having 2 video files to match up, this will do it exactly. And we can sort of replay and rewind to see at exactly what point the thing was doing what behavior. Anyway, so this piece here goes over horizontally like that, and it has another stopper that slides. I mean, it slides and then it's a bit tight because I wanted it to make it a really good fit. But when it gets, it's a bit hard to do with, there we go. So it's going to stop there, and then I just pull on this like that. And the reason, in case it wasn't obvious, the reason I've made this thing so long is because I only have this little 5 kilo load cell, and I'm pretty sure that we're not going to be able to get it to break with 5 kilos at this distance of torque. But this bar here is at 1.2 meters, and then there's another 10 centimeters or so to the point where the load cell is actually measuring here, which is where I'm going to pull on. Yeah, so I hope that 5 kilos at 1.3 meters is going to be enough to break all of these little test pieces here. Alright, let's start with the plain naked balsa and see how that goes. Something's gone a bit funny with my Arduino or the load cell, and you can see the graph, it's only moving when I'm actually changing the value. It's supposed to continually scroll to the left, but that's actually kind of a good thing, because it means as soon as we stop the test, the graph will stay there and it won't disappear. So anyway, let's give it a try. Oh, it's kind of slipping. Damn. Okay. Wasn't really. Okay, this is the 200 gram fiberglass. Oh, it's coming unstuck. 2 kilos though. Alright, well, it didn't really get much above 2 kilos. And it's lost its shape. Still holding 1700 grams though, sort of. Right, I think that'll do. So let's say 2 kilos probably. How well together is it? Oh wow, it's actually... Man, I don't think I can. No, I can't break it. At least not on this axis. I don't really want to get fiberglass on my fingers too much, but still got a lot of capability. Like if this was a plain wing spar, it'd be just fine. Probably it'd be misshapen, but it wouldn't be breaking. No. I kind of lost track of how much leverage I was gaining by using this long beam here. Okay, this is the plain weave carbon. Wow, it's I can hear it sort of coming unstuck already. It sounds like sellotape peeling off. Oh, it's slipping out, eh? Whoa, a sudden break there. Interesting, we didn't really get that with the fiberglass. So this half, the back is stuck on still, but this front half has come off. And then the balsa was able to break, I guess. So there is actually a pretty big crack in the balsa going about at least halfway through. Oh, okay. Oh, I see. Didn't notice that. Looks like the split along that weave there. So that loud crack was probably that. And the sellotape unpeeling sound would have been this slowly coming off. Yeah, that's one thing I considered doing here, was holding the workpiece down from the top as well, so that couldn't happen. Maybe I should have done that, but I'll just do them all the same now. And finally, let's try the unidirectional. Oh. No, it only, wow. So it only got to, hold on a second. 2.3 kilos. That's actually quite a bit less than the plain weave. I thought it would get a bit further, this one. Interesting. So there was definitely a loud crack of the balsa there. Still got a bit in it though. No, not really. It never got past 2 kilos again though. Okay. I think I might try the fiberglass again and see if I can really break it, because I didn't hear any of those like loud cracking, like sudden cracks from this. So Seems like the balsa itself is still intact inside here, even though it was a bit sort of more spongy as it bent. Actually, you know, looking at this now, it's in much better shape than the plain weave one was. Look, see, that ended up like this. This one, you can almost not even tell that anything's happened. And again, of course, if I try and break it by hand, it's just not going to happen. But if you look closely, you can see, maybe you can see a little bit of pale points here. I think that's sort of broken a little bit through there. And on this side, not going to show up very well on the camera, I think, but there's a sort of a crack that goes through about halfway to there. But this side, the fibres are all intact. And as far as the balsa goes, there's a big sort of a kink in the side there, and over here there's a crack. I'm not really sure how that happened actually, but you know, it's in a lot better shape, as in it didn't bend as much as the fiberglass one did. Yeah, so I'm actually thinking maybe this is better overall. If you want something to stay in one piece, you don't. It seemed to bend a little bit more than this one, so we didn't get that sudden crack, and it didn't support as much torque overall. But that could be partially to do with the way my system here is not very well set up. I'm trying to bend it around instead of what might have been better was to press on it directly like that, rather than like trying to bend it that way, because this keeps sort of slipping out of the end of these like jaws that I'm trying to hold it with. Anyway, let me see what happens with this again. There we go. Okay, so it actually came unstuck. Yeah, came unstuck quite significantly at the back. And now the balsa is actually ruined inside. Oh, and I can quite easily break it, so, oh yeah, look at that. Okay, so we're just about done. What I think I might do now is try and break this in the other axis. So, like, try and break it, like pressing that way. I'll just put the 2 kilo water bottle weight on it over the edge of the desk and see what happens. Okay, I'm going to place the 2 kilo water bottle at about the 6 centimetre mark, 6 centimetres away from here that is, but I'm already getting the feeling that 2 kilos is not going to cause it any concern at all. It should be about 6 centimetres here. Oh, did it even move? Oh yeah, it moves a little bit, but not much. Okay, I had a better idea. I just rearranged my jig a little bit so that we can try and bend it this way now. Alright, ready? Actually, we don't have anything to compare this against though, do we? Oh, this is easy now. Sudden crack. Oh, 2 sudden cracks. Okay, that's pretty much the end of it there. Okay, now I can break it easily. Yeah, now we've totally broken through all of the fibres on that outside. Oh, that's interesting. I didn't think the ones on the inside were broken, but I guess they were. Okay, so that was totally ruined at that point. But it took quite a lot to do it. Okay, that's going to do it for this video. I don't think there's really any need to do a summary because you've seen all the information the same as me. But just to give a few of my impressions about what we saw here, I was a little bit surprised that the unidirectional carbon didn't support more of a load overall than the plain weave. But there were sort of quite marked differences in the way that they broke. So the unidirectional carbon was still going quite strong even after supporting almost as much weight as the plain weave, so 3.08 to 3.59, it's pretty close, but the unidirectional weave was still alive and kicking very much after that. And I was also surprised to see that the glass deformed much slower, so it was also able to undergo more of a bend, like a larger angle, before it was totally destroyed, which was kind of interesting. But anyway, for my purposes, none of this really matters. From what I've seen here, it's not going to make any difference which one of these I use, although I probably will go with the unidirectional carbon because I've already have it, and it's a little bit easier to make a narrow width of this because I have it in the 25mm width. One thing I didn't mention about this was that cleaning up the edges of these pieces of balsa for the 50mm widths where they were sort of sticking over the sides, that was actually a bit of a nuisance because the resin hardens very, very hard, and I managed to cut through it with a craft knife and then sandpaper off. Yeah, but it's not a trivial thing, so it's something you do want to consider, the cleanup of the edges, how you're going to do it. Yeah, I'm already starting to think about things like that. It's good to have this experience because you can sort of look into the future and see where your annoyances and problems are going to be and try and avoid them. But anyway, yeah, I think that's the end of the video. I hope it was kind of interesting, and I'll see you next time. Thanks for watching. Bye.